Hi there folks, this is Mr. Jansen, and today we're just looking at a little bit of a kind of a remediation thing to help us with the last couple things we've been learning in terms of adding and multiplying polynomials and then doing the GCF. And you have a worksheet that you're working on right now to kind of go through some of that stuff again. This worksheet looks similar, but it is not the same one. This is just here to kind of help you and guide you so that you should be able to do that other one on your own. Okay? So if we take a look at this first guy, it says write the expression in standard form. Remember, standard form is descending order, so it goes by the exponents. When I look at the exponents here, I've got a 3. Here, technically, I have a 1, and here I have a 5. I just list the one with the biggest exponent first, so it's x to the 5th, then the 7x to the 3rd, and then the 5x. Okay, that's standard form when we list it in descending order according to those exponents. Okay. The next couple just say to find the degree and then name each based on the number of terms. So like when I look at the first one, again for a polynomial you look for the term with the biggest degree. So like this term has a degree of 3, this one has a degree of 1, so this is a 3rd degree polynomial. And then the type of polynomial, because there's 2 terms, we call it a binomial. The next one, again this one's not written in the right order, but if we were to write it in standard form in descending order, it would look like this. So now I can see the exponent. The biggest exponent is the 5. See, this term, degree of 5, this one's a 3, and this one's a 0. So this is a 5th degree. And because there are 3 terms, we call it a trinomial. Okay? And really, for most polynomials, just the biggest exponent. If we run into a case where there's more than one variable, like in this last one, so you have 2 variables here and they each have an exponent of 1. When there's more than one variable as part of one term, I have to add the exponents together. So this is a 2nd degree. And because there's only one term listed here, there's no addition or subtraction, so there's not multiple terms, I call it a monomial. Okay? Next one, add or subtract each polynomial. Remember, when we're adding, we just combine like terms. Like terms have the same variables with the same exponents. So when I look at these guys, the 5x squared and the 2x squared, those are like terms because they have the same variables and the same exponents. So I just add them up. It's a 7x squared. And again, when you add these together, the variable part does not change. That's why we need to have like terms before we can add them, because we're not doing anything with the exponents. They have to stay the same. Here, these guys are like terms, the 3x and the negative 6x. When I add those together, it gives me a negative 3x. Once again, the variable part does not change. It stays the same. And then the negative 8 and the negative 3, that adds up to a negative 11. And that's it. Okay? The next one, subtraction, the suggestion that I always make with subtraction is always distribute that negative first. So let's distribute this negative, and then we'll just be able to combine like terms. So the first guy, this didn't have a negative in front of it, so it doesn't change. It stays exactly the way it was. And now I distribute the negative. That's a negative 3x cubed minus 5x and a plus, plus 3. Now I look across and I combine like terms. So like I always go from least to greatest, so I look for the biggest exponent first. This guy right here, the x cubed, there are no other x cubes floating around, so there's no like terms I can combine. That one just stays the way it is, so I write down the negative x cubed. Same thing with the x squared. I look across and I don't see any other x squared, so that guy kind of stands alone. I just write him down. The x terms, those are alike, so the 7x and the negative 5x. Again, when I add them together, that's a plus 2x. The variable part doesn't change. And then the negative 2 and the positive 3 add up to a positive 1. Okay? So distribute the negative, combine like terms. When you combine like terms, the variable part stays the same. You have to have like terms. This one, we're just going to distribute that term that's out front. And again, this whole thing, all of this gets distributed to each of these guys. Okay? And this is just our rules of exponents as we go. So like 5 times 2 is a 10. But now when I multiply this, see this is next to the first, I add the exponents. X to the first times x to the second is x to the third. y to the second times y to the second is y to the fourth. The next one, 5 times a negative 4 is a negative 20. I add the exponents, so x to the first times x to the third is x to the fourth. Y to the second times y to the first is y to the third. Next one, 5 times 3 is a 15. Each of these has a 1. I add the exponents. That's x to the second, y to the third. And that's it. Okay? So we're distributing. We're doing some multiplication. We just have to remember our rows of exponents as we do that multiplication. Here I distribute the 4x. That gives me a 4x cubed. Again, I multiply, so I add the exponents. And a negative 12x. Over here I have the distributive property again, so I'm going to distribute that negative 6, and make sure you distribute the negative sign with it, so that's a negative 12x and a plus 24. And now I combine any like terms that I have, these two in the middle. These are like terms. A negative 12 and a negative 12 gives me a negative 24, and it's a negative 24x because the variable part does not change when I combine like terms. Okay? In this one, I can use my distributive property, or we can call it FOIL if you want. We can do FOIL. But I just take the x and I distribute that to each of these. So x times the 5x is a 5x squared, times the 2 is a plus 2x. Then I distribute the next term, which is the negative 6. And again, it's a negative 6 that's being distributed. So it's a negative 30x and a minus 12. And notice the rules of exponents that happened there when I did the x times the 5x. I added the exponents. That's why it's a 5x squared. Now I combine like terms. These two in the middle are alike. That's a 5x squared minus 28x minus 12. The next one I'm going to go ahead and distribute. So I distribute the 3x to each of these. Again, I'm using these rules of exponents. I go 3x times 6x. That's an 18x squared because I add the exponents. 3x times a negative 1 is a negative 3x. I distribute the negative 4. That gives me a negative 24x plus 4. And then I combine like terms. So I've got 18x squared. Again, when I combine like terms, the variable part doesn't change, so that's a negative 27x. The next one, same kind of thing. I'm going to do my distributive property, or FOIL, the whole first, outside, inside, last. Either way, you're going to multiply these in the same order, so I'm going to distribute the 7x to each of these. That gives me a 49x squared. I add the exponents when I multiply, minus 14x. I distribute that 2. Again, I'm distributing a positive 2 this time, so that's a plus 14x, and then a minus 4. And then I combine like terms. When I combine these two in the middle, a negative 14x and a plus 14x gives me a 0. So I'm just left with 49x squared minus 4. Okay? That's one of those things we've noticed that always happens when I have what we call conjugates, which is the same binomial with different signs in between. Okay? If I have a binomial squared, I need to write the binomial twice. I can't just square each piece. I have to write 4x plus 5 times 4x plus 5. And now I use that distributive property that I've used in the previous couple examples. I distribute the 4x to each of these. That gives me a 16x squared plus 20x. Then I distribute that 5 to each of these. That gives me a plus 20x and a plus 25. And now I combine those like terms, those middle terms, the 20x and the 20x gives me a 40x. And that's it. So all of this comes down to distributive property, and when we're multiplying distributive property and our rules of exponents. And then a little bit of combining like terms. Remember, when you combine like terms, variable part stays the same. Okay? This one I'm going to distribute the 3x to all three of these pieces. Again, just using my rules of exponents as I go. That's a 3x cubed minus 15x squared plus 12x. And now I'm going to distribute the negative 8 to each of these. And again, that is a negative 8 that I'm distributing. So that's going to give me a negative 8x squared plus 40x minus 32. And now I start combining like terms. So I look across. I notice that the 3x cubed doesn't have any like terms, so he stays the way he is, 3x cubed. The x squareds I can combine. I've got some x squared terms here, the negative 15x squared and the minus 8x squared. That gives me a minus 23x squared. Again, the variable part doesn't change. The 12x and the 40x, I can combine those, and that gives me a plus 52x. And then the minus 32 doesn't have anybody to combine with. There's no like terms for him, so he just tags along for the ride. Okay? Greatest common factor. Factoring is the reverse of our distributive property, so if the distributive property is multiplying something in, factoring is dividing it back out. Okay? And so factoring, you just look at each of these and say, what can I divide evenly out of the 12 and the 30? And I want the biggest thing that I can divide is a 6. Okay? And then I look at the variable and say, what variables do they have in common? They don't have any in common, so I can't pull any variables out. Okay? And so I put the 6 on the outside of the parentheses, and I divide it out. And so here's what's happening. I just say, okay, this guy divided by 6, this guy divided by 6, and I write down what I get. That gives me a 2x minus 5. And that's it. That's factored form. And you notice if I were to distribute, I'd be back to the original problem. Okay? Next one, same kind of thing. I look at the 5 and the 15. I say, oh, I can divide a 5 out of those. And then I look at the variables. I say, oh, an x squared and an x. And I just kind of think of it as, okay, x squared is 2x's, x to the first is 1x. So if I want to pull something out of there, the most I could take out is x. Okay? I can't pull out any more than that because this second one only has 1 to spare. Okay? If I have a y to the fourth and y squared, the most I could take out would be a y squared because that second one, again, only has 2 of them to spare. And now I do the division. I divide that thing out of there, and I'll actually show it. So I just divide each of these by the thing that I just wrote down, by that GCF. And so here I get 1, again, x to the first, y to the second. I'm subtracting the exponents. That's my rules of exponents. Here I get 3. X to the first divided by x to the first completely cancels out. Y to the second divided by y to the second completely cancels out. So I'm just left with the 3. And that's it. You're dividing it out. And a lot of students are really reluctant to show this little step of doing the division here. You just sometimes need to show that, and it'll really help you with these problems, I think. Next one, between a 14, a 22, and a 6, I think the only thing I'd take out is a 2. Then when I look at an x to the fifth, an x to the third, and an x, well, if one of them has 5, one of them has 3, and one of them has 1, I have to take the same amount away from each. The most I could take away is x. Okay? And so now I set up my parentheses, and I say, okay, let's divide each of these. So divided by 2x. I'm just dividing out that greatest common factor. So I identify the greatest common factor, and then I divide out that greatest common factor. So here, 14 divided by 2 is a 7. I subtract the exponents. That's x to the fourth. Here, that gives me an 11, x to the second. Again, I'm subtracting the exponents. Here, I get a 3, and the x's cancel completely. And that's it. Okay? Next one, same kind of thing. Between 6, 15, and 21, I can take out a 3. And then I look at the a squared, a to the first, a to the third. The most I could take away is an a to the first. Between b to the first, b to the second, b to the third, the most I can take away is b to the first. And so that's what I'm going to divide out. So now I actually do the division. So I come over here and say, okay, I'm going to divide each of these by 3ab. And now this is just my rules of exponents. I divide the coefficients. 6 divided by 3 is a 2. I subtract the exponents. That's a to the first. And the b's cancel. Here that gives me a minus 5. The a's cancel. B to the first. Here I get a plus 7. I subtract the exponents. That's a to the second. B to the second. And that's it. Okay? So identify the greatest common factor. What's the biggest number that divides evenly into each of them? And then from there, you're just saying, okay, what can I take out in terms of the exponents? And then you divide it out. Okay?